5.1 Objective. Write fractions as decimals and decimals as fractions. The vocabulary you need to know for this lesson are rational number, terminating decimal, and repeating decimal. A rational number can be written as a fraction p over q. Okay, and a terminating decimal will be a rational number p over q, and when you divide p divided by q, it will end as a whole number with a remainder of 0. So say, for example, if I give you 3 divided by 4, this will give me 0.75. Okay? And for a repeating decimal, it's also a rational number p over q, but when you divide p and q, it does not end. It repeats and repeats and repeats. Okay? So just 2/3, which equals 0.6 repeating. Okay, and here I have a chart which you can take a look at the difference between the terminating decimal and repeating decimal, and they both are rational numbers. Okay, guided practice. To show that the number is rational, you would write it like this. For 24, you will write it as 24 over 1. For negative 1 over 8, you would either write it as negative 1 over 8 or 1 over negative 8. And if you're given a mixed number, you will want to write it as an improper fraction. Okay? So this would be 97 over 18. And if you're given a decimal, a terminating decimal, then you will put it over 100 because there are 2 decimal places to the right. And simplify, but 87 and over 100 is already simplified. Okay? Part B. Write the fraction or mixed number as a decimal. So 3 over 8. I'm going to avoid division if I can. So I'm going to multiply by 125. So to get 1,000. 3 times 125 gives me 375. So my answer would be, okay, after shifting the decimal 3 places to the left because I have 3 zeros, will be 0.375. Here, I can copy the 1 and simply convert this to a decimal. Okay, so 20 times 5 is 100. 9 times 5 is 45. And I can shift the decimal here 2 places to the left to get 1.45. Okay, and for 29 over 80, I can do the same. Times 125 to get 1,000. I'm not going to forget the 0 here. Okay, and 29 times 125 will be, after doing some multiplying, you should get 3625. And then because we have 4 zeros in the denominator, we can shift the decimal 4 places to the left to get 0.3625. Okay? And before I do the next problem, I would like to show you a little trick or pattern. Okay. We know that 1 over 9 is 0.1. If you do a simple division, okay, you see, 1 repeats over and over again. So dot, 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 dot. So your answer will be 0.1 repeating. Okay? So if I continue a pattern like this, right, 2 over 9, it will be 0.2 repeating, 3 over 9, 0.3 repeating, and if I'm given 12 over 99, be 0.12 with 1, 2 repeating. If I'm given 456 over 999, it will be 0.456 repeating. If I'm given 78 over 999, okay, then 1, 2, 3, and it will be 0.078, okay, boom. Alright, and what if I'm given, before I explain what I wanted to explain, I can therefore conclude that the number of 9s in the denominator tells me how many place values repeat in the numerator. Okay? So let's take a look at this example, 2/3. Times 3 times 3, I would get what? 6 over 9. Okay, I got 1 9 in the denominator, so my repeating decimal will be 0.6. Okay, and same thing for 11, 5 over 11 times 9 times 9, so I get 45 over 99. You see I have 2 9s in the denominator, so I know it's going to be 0.45 repeating. Okay? It will only work in this case. But what if I'm given, let's see, a numerator that's bigger than the denominator? Then you'll need to change it to a mixed number so that the numerator, the number of digits in the numerator either equals to the number of digits in the denominator, or the number of digits in the numerator is smaller than the number of digits in the denominator. So we therefore can conclude this 1.36 repeating. And if you punch in the calculator, you'll get this as your answer. Okay? And if we give a mixed number like 1 over 6 over 99, then you know that your repeating decimal will be 1.06, okay, with 0.6 repeating because you got 2 9s. Okay, and again, this only works for this scenario. And let's move on. So here we have this mixed number, and we could use the little trick. And you see, my goal is to avoid division if possible. Times 3 times 3. So 28 times 3 is 84. 33 times 3 is 99. The number of digits in the numerator equals the number of digits in the denominator. Okay, satisfy that rule. So your answer would be 5.84 with 84 repeating. Okay? And for the next problem, we need to do a little division. Okay? So first I'm going to write this down, and my division will be 29 divided by 60. I'm going to set this up. 4, 240, 500, then 8, 480. This will give me what? 200. So 60 times 3, 180. Okay, and it's against me another 200. Oh, I found a repeating 3. So again, the 3 repeats. So your answer would be 483 repeating, which was not that bad. Okay? Now, we're going to have to write the decimal as a fraction or a mixed number. So, we need to take -3 and then put 5 in the numerator and write 100 in the denominator because we have 2 decimal places to the right. Okay? So some of you may be wondering, why are we doing that? Okay, if we take this fraction apart, then, hey, times 100 times 100 in the numerator, 5 over 100. Okay? Most of you probably know that already. So here we have -3, and let's shift. Simplify. So 1 over 20. And here we have 54 over 100. 54 divided by 2 gives me 2, and 27. 100 divided by 2 gives me 50. So 27 over 50, that's in the simplest form. Okay. And then the next one, we get -5. 85 over 100. Again, we need to simplify. 85 divided by 5, I would get 17. 100 divided by 5, I will get 20. So this gives me -5, 17 over 20. Okay. Now we need to convert repeating decimals to fractions. Okay, so let's take 0.93 for example. And we're going to let that equal to x. Okay, because there are 2 repeating decimal places, 9 and 3, I'm going to multiply x by 100. And because I multiply 100 on the left side of the equation, I would like to shift the decimal to the right 2 times. Okay? And then I would get 93.93 with 9 and 3 repeating. And then I'm going to take this down here again. X equals 0.93, so my repeating digits line up. And then I'm going to do some subtraction. 100 minus 1 is 99x. Okay, and 93.93 repeating, subtract 0.93 repeating is 93. Divide both sides by 99. I get 93 over 99. Okay, and then I can do a little simplification here. 93 divided by 3, we get 31. 99 divided by 3, we get 33. And so your final answer is 31 over 33. Okay, and another way to look at this is, see, we have 2 digits that are repeating. I can simply put that over, hold on, here, 93 over 99 and simplify to get 31 over 33. And this is the same idea as what I was talking about earlier over here. The number of 9s in the denominator tells me how many place values repeat in the numerator. So since 2 digits are repeating in the numerator, then I know my numerator has to be 93, and I just simply put it over 99 because I only have 2 digits repeating. Okay? And this is the entire proof for it. So after I put, if you want to take the shortcut, you just have to remember to simplify. Okay? So again, I could just do the shortcut. I only have 1 digit repeating, so I can just say 8 over 9. And if you don't believe me, let's let x equals 0.8 repeating, because I only have 1 digit repeating. I'm going to multiply x by 10. Okay, and then the decimal here would therefore shift right, because whatever you do to one side of the equation, you got to do the same thing to the other side. And so basically I multiply by 10 to the right hand side of the equation as well. Okay, and this will therefore be 8.8 with the 8 repeating here. I'm going to take this down here. X equals 0.8. Okay, and now I'm going to do some subtraction. 10 minus 1 is 9. X. Okay, and this goes out, and 8 minus 0 is 8. Therefore, 8 over 9. As you can see, this 9, okay, and this 8 comes from here. Alright. Here, same thing. This will be 25 over 999. The number of 9s tells me that there are 3 digits repeating, okay, in the numerator. So again, I'm going to work this out. Let x equals this, and then because I have 3 digits repeating, I am going to multiply by 1,000, 3 zeros. I'll get 1,000x, then I'm going to get this 3 shifts to the right. So 25.025 repeating, and I'm going to take this down. So I would get x equals to 0.025. Alright, and then let's do some subtraction. 1,000 minus 1 is 999x. Cancel. 25. X equals to 25 over 999. 99, and that's it. Okay, and then for the next problem, I would like you to work out the steps because it's a little special. See, one digit is not repeating, and you have two digits that are repeating. Okay, so let x equals this again, and then because I have two digits repeating, I'm going to multiply by 2 zeros, so 100x. Whatever I did to one side of the equation, I also need to multiply by 100 to this side of the equation. So shift the decimal 2 times to the right. Okay, and then I will continue to write 1, 2 repeating. And I'm going to take this down to get x equal to 0.012. And as you can see, my repeating bar lines up. Okay, and I'm going to do some subtraction. 100 minus 1 is 99x, and this goes out, and you have 1.2. And I'm going to divide both sides by 99. Now, you need to shift one place to the right, and whatever you do to the numerator, you do to the denominator. So you get 12 over 990. 12 divided by 3 is 4. 990 divided by 3 is 330. And that's it. And for the next problem, we would do the same thing. So let's practice again. Let x equals, okay, and since we have two digits that are repeating, we would like to multiply the x by 100x, and therefore we can shift the decimal 2 places to the right to get 21.6. And I would like to continue to write 1/6 with a repeating bar on the top. And then I'm going to take down this here to get x equal to 0.216. And then I'm going to do a little subtraction here. Boom. Okay, cancel that out. 100 minus 1, 99x. And this would be 21.4. Okay, I also subtract this part. And this would be x equal to 21.4 over 99. And I'm going to shift one space to the right, both in the numerator and the denominator. So this will equal to 214 over 990. And now I need to simplify. Okay? So after I simplify, I would get 107. I would 495. Oh, sorry about this. There you go. Okay, if you punch in the calculator, you'll get 21 point. Just kidding. 0.2161616. Okay, and let's move on. Ordering rational numbers from least to greatest. You don't have to use a number line to do this, but I am going to use a number line to show you how to not make careless mistakes, okay? So negative 5 over 4 on the number line, it would be where? It would be negative 1 right here, okay? Because negative 5 over 4 equals negative 1 over 4. Okay? And negative 0.2 would be right here. 4.31 is about right here. Negative 3. 5 over 2, which equals to 2.5. So we got 5 over 2 right here. Negative 13 over 3 gives me negative 4 over 1/3 will be here. So I'm done. So I'm going to order my numbers from least to greatest now. Again, you do the way you're comfortable with. Okay, you don't have to use a number line, but my suggestion is to use one so you do not make a mistake. Okay, let's do another practice problem. Negative 2 is right here. Negative 7 over 8 is about right here. Okay, 0.8 is about over here. 2.1 and 1 1/3. And we're ready to write our answer. Oh, I should have circled this. This is our answer. And then this one would be, oops, okay, 0.8, 2.1. And that's it.